Today we're going to talk about how we can make Spring Boot integration tests faster. So my motivation behind this talk was that in my experience, some of the Spring Boot, especially Spring Boot tests that I've worked with, tend to be frustratingly slow. And that's in part because in my opinion, because Spring Boot tried very hard to lower the bar to entry and make very simple abstractions. However, sometimes they don't scale quite the way we would like them to. Today I'm going to show you, actually, here, let me show you this slide. What we're going to see today, first we're going to look at Spring Test Context, which is the test framework used to run Spring integration tests. Then we're going to look at test slices as they were introduced by Spring Boot. I'm not going to discuss the actual test slices today because they're well documented. They're mostly also well known, but we are going to look at how they work and how we can take advantage of that to kind of roll up our own test slice or test recipes, as I call them. And then we're going to spend the third section of this talk looking at a few recipes on how to test things like method validation, method security, caching, and aspects with tests that are as lightweight as possible. And we're going to see that this enables us to have more flexible, more decoupled, and overall tests that are easier to work with. What did I want to say about this? Oh, okay. So I'm going to say integration tests. Whatever you think an integration test is, please, for the next 40 minutes, forget it. And I've had people tell me, like, this is not what an integration test is. So when I say integration test, I mean a test that uses Spring Test. So that's all I mean. So Spring Test or Spring Test Context, I'm just going to say Spring Test today because it's easier for a poor francophone like me. So what Spring Test does, or actually Spring Test, you know you're using it when you have a test class with maybe a bunch of annotations on it, things like add Spring Boot test, add context configuration, extend with Spring extension, or run with Spring JUnit 4 runner, I think it's called, or whenever you start a test class and then you see the Spring banner going up, or you see a bunch of logs, then you know you're in the presence of a Spring test suite. So what Spring Test does is that for every test class you have, it's going to start an application context. And in application context, I'm not going to go into too much detail into exactly what it is, but for now, for today, it's sufficient to know that an application context is basically a Spring application. So what this means is that effectively Spring Test starts a Spring application for every test class that you have. And this is why sometimes initialization is so slow. Spring sometimes has slower initializations. There's a lot of things to load, and that's why your test sometimes can be a little longer to boot. However, Spring Test has a clever optimization for this. It's able to reuse these application contexts for various test classes. So in some situations, it's going to be able to start one application and use the same application to run your test methods from other test classes. For this, however, to occur, your test suites have to have configurations that are absolutely identical. So your application contexts have to be configured in ways that are absolutely identical. How do you know this? Well, unfortunately, there's no easy way to know it, or there's no on-off button that says make this identical. You know they're identical when you have the exact same set of annotations, when the properties are the same, when everything that would configure your test, how it runs, is the same. So all of these annotations on it, they all configure somehow your application context, and they become part of the cache key that Spring Test uses. So I want to show you what this looks like in practice. And here I have a test that's pretty standard. This is a Spring test. It says add Spring Boot test. And I'm using 3 beans here. The first one is called bean 1. It's a scheduled bean. All it does is every second it logs context 1 is running. I'm also importing context caching config, which has a terrible name because it enables scheduling and not caching. And finally, I have a third bean here called slow bean, and this is just my way of simulating an application that has a bit of a heavier initialization, maybe a file that needs to be downloaded, maybe a connection pool that needs to be initialized, whatever. The point is, I'm in a very small hello world type application, and whatever I want, or whatever I would do here, initialization would still be pretty fast because it's a rather small application. So all it does is it logs initializing slow bean, it waits for 5 seconds, and then it unblocks. So if we run my test, we're going to see, well actually it's pretty obvious we're going to see, just a second. We're going to see initializing slow bean, we're going to wait for 5 seconds, and then it's going to go through. And yes, please, you had a question.
Yeah, I'm sorry, I'm not a Spring dev, but is that how you inject dependencies? Like classes that you have, those are the dependencies.
This is how you declare them, how you inject them. There's a few ways. One would be at auto-wired, and then I could access bean1 this way. I would have access to the bean1 that's in my application context.
So you use auto-wire annotation?
Yes, there's a few ways. That's one of them. And by the way, if you have any question, then please feel free to put your hand up, and then I'll be more than happy. And even if you have a question, there's something you don't understand, or maybe I wasn't clear enough, it's always a good indication to me. Maybe I skipped something and it's not clear, so it kind of gives me an opportunity to be clear about maybe something that I missed. So what we're getting at is that context 1 test, what it does when we boot it is it waits 5 seconds and then it unblocks. Here I have an other test class that's called context 2 test. It's absolutely identical, except that instead of importing bean1, it imports bean2 here. So if we look at bean2, it's pretty similar to the other one. It's every second it's going to log context 2 is running. And maybe you're following, well actually let me show you. If we run this, again it's pretty obvious what's going to happen. Initializing slow bean, we're going to wait for 5 seconds, and then this unblocks. So kind of my way of simulating what an integration test in a bigger application would be like, or would feel like. Now what I want to show you, and that's what is most interesting about this, is if I run my whole package here, or even if I run all of my tests. This simulates maybe you're running all of your test suites just to make sure your fix is correct before pushing to GitHub or GitLab, or maybe you're in CI and you're waiting for your pipeline to be green. So if I run, if I run my package here, what we're going to see is the 2 tests are going to be run. And the first one is going to wait 5 seconds, it's going to unblock, and then the second one is also going to initialize and wait for 5 seconds. So again, you run into these situations quite often where you have multiple initializations of different application contexts in your same set of tests. So what I want to show you here is that we can actually take advantage of Spring Test's ability to cache and reuse application contexts. And as I said, the way we do this is by making sure that both setups are absolutely identical. Now, how do you do this? Well, it varies, or it depends based on your application logic, based on what's acceptable to you. Here, maybe as an example, it would be acceptable to me to load both bean1 and bean2 in my 2 test suites. So I'm going to do this. I'm going to say both load bean1 and bean2. And now, well, they're both going to be identical. So if I run my whole package, we're going to see that we wait 5 seconds, and then the second one runs instantly because it was able to reuse the setup from the first one.
Is the order important?
If the order is important, no. Here, I can do this and we'll still get the same optimization.
What if the second test will only have bean1, not both bins?
Say again?
Like what if first test has both bins?
Yes.
The second one only like bean1?
Yeah, let's try it. Second one, let's take one of them away and let's see what happens. And what happens is we wait 5 seconds, and then we wait 5 seconds again, because both are not identical. And thank you for bringing me back to a point where they're not identical. Yes, I'll get to you in a second. Something I want to show you that maybe is going to be a better example of what Spring Test does is that if we get both initializations, during the second one, we're going to see some logs here. And here I'm just going to wait until it finishes, and I'll put them up again. What we see if we look at the logs of context 2 test, we see initializing slow bean, and then every second we still see context 1 is running. And that's because the first one is still running in the background, because Spring Test is hoping that it's going to be able to reuse it for some other test suite. And yes, you had a question.
Can you use a qualifier or something to make the priority more advanced?
The priority?
Using the qualifier or something, primary tab, annotation.
Could you give me an example?
Like if you want, without injecting a bean from the classes annotation, we can use a primary bean through auto add, to make that higher priority.
Yes, you get. If you use qualifier, it's going to be able to. It's going to be used to distinguish between various various auto wiring candidates, but it's not going to affect this behavior. At the end of the day, the cache key is still the configuration of the application context. So as soon as something varies, qualifier is different, a bean is different, no reuse.
Even the primary annotation as well?
Correct. Yeah, because that would affect which bean gets auto-wired as an auto-wire candidate. Okay, so this is a way that you can simplify or maybe lower the latency or the total running duration of your tests if you have multiple heavier test suites and you want to save time when you run all of them at once. So this strategy that's more helpful if you're dealing with maybe an application that already has, let's say, 15 different test setups that each wait 30 seconds, then maybe if you find a way to find some common ground between all of these setups and say all of them now will use this one setup that's appropriate for all of them, then you might be able to save, 14 times 30 seconds in my example. Yes, please.
Quick question. As you're trying to find this common ground or common denominator
Yes.
in the context between the tests, are there any, I don't know, maybe logs or something that's coming from the Spring test
Yes.
that could help you know whether it's reusing and why not reusing?
Yeah, so the question was, is there a log or something that you could watch to verify, what the context reuse looks like? Yes, there is, and no, I do not remember exactly what the package is, but there's a package in, I think it's spring.test.context, where there's a class in there that logs the cache metrics. And if you look at the documentation in Spring Test, it'll say, if you want to have this information, bump this up to debug, and then you'll get those logs. Yes, please.
But is there a way to express this commonality in a very explicit way, to say, I have something and I want to use it here, 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 because I want to avoid a situation when someone joins the project and comes to a test and just, I'll add this one more
Yes,
in,
yeah.
all of a sudden I lose my
Yeah, and that's a
commonality.
super good point, and it's exactly what I was getting at. So thank you for this nice segue. The question was, how do I make sure that they're all identical? And say someone, right now, I made them both identical because I made a conscious effort. I looked at both of them. What if someone joins the team and works on this test and says, I also need bean 3 here, so I'm going to add it, and no harm done? Well, yes, harm done, because you're not going to get context reuse. What you can do, and what I suggest that you do, it's what I personally do, is you can take this, copy it out, and create a new annotation that says, this is my canonical test setup that will work well for testing Kafka or testing whatever, whatever common thing that I want to test in my application. So you can create a separate annotation, then you just copy paste your whole test setup on there. It's very important if you do this that you write retention and runtime like this, because by default the Java compiler will strip away the annotations so they won't be available at runtime, and then you'll get into some really frustrating issues where somehow it won't work, and but basically you need this if you want an annotation to have an effect at runtime. So this is my suggestion. It's very easy to create an annotation with your whole stack of test annotations, and then you can reuse it everywhere. If you choose to do this, yes, I'll get to you in a second. If you choose to do this, bear in mind that you'll still run into issues if you have, for example, fields that are annotated with mock bean or spy bean or Mockito spy bean, Mockito bean, because these also affect context configuration. Yes, you had a question.
Is it possible to have a super class, like a common class, and then have other classes extend that super class?
Yes, it is. That would work. However, my recommendation is that in this situation, or in situations like this, I personally would favor an annotation for two reasons. The first one is there's no multiple inheritance in Java, so if you ever need an actual superclass, then you're stuck. You can't add another one. The second reason is that, and that's more kind of a software design thing or principle, in my opinion, inheritance is best used to express a is-a relationship. So for example, I've seen many classes called base IT. Then the question would be, is context one test a base IT? And then you get into an issue like, what's a base IT? What can be a base IT? It doesn't really fit, I think, what inheritance is best used for. That's my very personal opinion. And there's, for example, you would never run into an issue where you want a situation where you would want to have a variable that's typed base IT, and you won't want to swap out implementations. So that's my very personal answer to this. But both work. I would personally favor the annotation. Yes,
One
please.
question, because you just started talking about like how mock beans of spy would affect this annotation. Could you elaborate please on that?
Yes, of course. So if you add mock bean here, let me Control Z. I think I can get it back. Yeah. Mm-hmm. If you add mock bean here, this is going to tell Spring Test, I want to have a bean in the application context. That's going to be a mock. Excuse me. So effectively, this has the same effect as if you had mock bean, slow bean, and if you had at auto wired here, slow bean dot class. There we go. So it's the same thing. So this will also configure your application context and configure in a way that will make it non-reusable. So if you want to do this, if you want to have, let's say you always want to have the same bean that's a mock bean, then you can always take this and put it on at my IT, and then you access it using at auto wired in your test classes.
But then it's going to be mocked on all of the tests.
Yes. That's very dependent on your very specific testing logic, whatever you want. But yes, it's going to have that effect. What I've done sometimes to kind of find a compromise between I want to save time when I run everything, but I want this bean to be a mock in one of my test classes, is you can use a spy bean, and then it's going to behave as if it was the same implementation. Except when you explicitly say, I want you to be a mock or something.
But then, because it's a mock, it accumulates all the state from all the tests, right?
No,
how many times?
no. Mockito beans or these types of beans will be reset after every test method or before. I forget. Yeah. Okay. So. Now let's look at, this was my strategy to deal with larger test suites. Now for the remainder of this presentation, I'm going to be talking about how to build smaller test suites. So this was kind of my take on what to do if you're stuck with larger test suites, or sometimes they're necessary. But for the remainder, we're going to look at how we can build smaller test suites so we don't have to deal with problems like this. One thing that you will notice is that for all of the other testing strategies that I will propose will not result in reusable contexts, but it doesn't matter because the tests will be a lot faster. So I want to talk about test slices in Spring Boot. Test slices are these annotations here. I'm sure you've seen them before if you work with Spring Boot. Add web MVC test, data JPA test, data JDBC test, REST client tests, and there's dozens of them. They're well documented, so I'm not going to show how to use them or explain them in detail. However, I do want to show you or want to discuss with you how they work and how we can take advantage of that. So test slices, what they do is that they allow you to start an application context, so a Spring application that's going to be only a subset of your application, thereby making your test more isolated and faster. To do this, test slices control two things. First one, they control what gets loaded, which of your user beans gets loaded in your application context, in your test. And they do this by applying a filter on component scan. Component scan is just when Spring looks at all of your classes, figures out which ones are annotated with @component, @service, @repository, or basically which ones it needs to register automatically, and then it's going to apply a filter on top of that. So for example, web MVC test will say, I want to scan all of the user's application, but I only want to retain beans that are @controller, @controller advice, and I think there's others that I may forget. @data JPA test will do the same for @repository, @REST client test, I forget, but they all kind of do this behavior of filtering out which parts of your application they want to load. The second thing they do is they control auto configuration. Now, I won't have the time to go into much detail about what auto configuration is, but suffice it to say that auto configuration classes are a way to configure your application from the inside out. So from libraries, they are going to configure your application. Sometimes you have configuration classes inside your application to configure your application. Auto configuration classes are similar, but they live in your libraries and affect your application. So we're going to take advantage of this to roll our own test slices. And why would we want to do this? Well, we want to do it because Spring Boot test can be costly. If you look at tutorials on how to test Spring or Spring Boot, especially Spring Boot online, you'll find Spring Boot test used very liberally. And the reason is because it's simple, and for smaller applications, it works well. And it still results in pretty efficient tests, because the default behavior of Spring Boot test is to just load your whole application. So start up your whole application. Therefore, if you have a Hello World application, it doesn't matter if you load the whole thing, it's still going to be pretty fast. However, if you start developing an application like this, well, over the years, things tend to grow in complexity and in initialization time, and therefore you'll end up with tests that might take a few minutes to load, or a few tens of minutes if you're really unlucky. So today we're going to work on kind of taking the opposite idea. Instead of just loading everything, we're going to see how we can load exactly what we need. And we're going to see that by doing this, we get a lot more flexibility from our tests, and our tests are not going to be as coupled with to unrelated concerns. For example, if you use @SpringBoot test and you want to test your repositories using this. Maybe one day someone adds a Kafka broker to your application and then your repository tests break. Or maybe you have controller tests and someday someone switches the database or uses a different database and your controller tests break. These are things that do happen in practice. However, if you start just what you need for an integration test, then it's not going to happen. So, now we're going to look at a few recipes to test Spring. And for all the recipes, we're going to follow a very general template. First, we're going to import the relevant parts of our application. Remember that that's what test slices did. And we're going to do this in one of three ways. The first way, actually there's two ways we can disable the load everything behavior of @Spring Boot test. The first one is if we specify classes explicitly, like here. The second way is if ever there is an @configuration nested class in your test class, Spring Boot test will disable its load everything behavior. So we're also going to look at some of that. And then finally, we might also look at @component scan, in which we can give a string that represents a package name, and that directs Spring Test to load only that specific package of your application. So the second thing we're going to do in our recipes is we're going to import only the relevant auto configurations. I'm going to give you some class names in our recipes. There's some mnemonics. They're fairly easy to discover. Excuse me, but you don't have to know them by heart. If you want to refer to my code examples, there will be a QR code at the end of my slides, and I will give my slides to Teresa, so you can refer to it, or I'll show you some ways you can discover them pretty easily. Make sense? Mm-hmm. Okay, cool. So let's look at some diet recipes, like diet spaghetti. Apparently that's what AI thinks a diet recipe is. Okay, so the first one I want to show you is method security. Method security is when you have @pre-authorize, post-authorize, pre-filter, post-filter, secured, roles allowed, all of these security annotations that you add on your methods to say whether or not you want to allow an invocation to go through based on some condition. We're going to use 3 ingredients. We're going to use @Spring Boot test. We're also going to disable the load everything behavior by specifying a nested configuration class. And finally, we're going to identify exactly what we want to load from our application using an @component scan annotation. So let's see how we can do this. And here's my security package. I have this bean here, secured bean. It has one method with an annotation that says, I want to let the invocation go through only if the argument is true. So this is a very simple one. I've seen some that are obviously much more complex, but this is something that you might want to test, right? Security, we kind of want to test it. Now, how do we test this? Well, as I've said, the recipe, excuse me, remove that. The recipe is fairly straightforward. @Spring Boot test here with a nested configuration class and a component scan application that identifies the package where my beans are. And once we do this with these 3 simple ingredients, what we can then do is auto wire in. Someone asked me about injecting a bean. That's how we do it. Auto wiring our secured bean, and then we can perform assertions on it. And just to show you that I'm not lying about these being pretty fast tests, it's not instantaneous, and I am on a Mac M2, so everything is rather fast on this computer, but still this is fast enough that I would be comfortable doing faster development iterations or things like TTD with such a test, as opposed to a big Spring Boot test that might be annoying to load, and you'd code up a bunch of things, and then at the very end you would try and see if what you've been working on for the last 30 minutes do work. With these tests, you can actually run them every second if you want. So that's my first recipe. Are there any questions on this?
So you need to combine, because I was under the impression that you can either do configuration or limit the classes.
Yeah, there's a few ways of doing it. If any of the conditions is true, the conditions being if there's an explicit class here, or if there's a nested configuration class, you won't get the load everything behavior. It's actually in the document. That's not nice. It's actually in the documentation somewhere in here. I forget. Okay. Yes, please.
If you could comment out that configuration component scan and
Yeah.
config subclass, as well probably as the classes in the Spring Boot test, and just give us an impression of how it would run.
Yeah.
loading the whole application context.
As I said, it's a pretty small application, so
Oh, you maybe wouldn't see the difference.
we might, but basically the idea is that this is O of 1. It's always going to take the same amount of time to load. See, we're seeing initializing slow bean. But if you use Spring Boot test with, by default, it's O of n on the size of your application. So as your application grows, then your initialization time will grow. So roll this back. Now let's look at our second recipe, and that's for method validation. Method validation is whenever you have @validated, @valid, @not null, @pattern, not empty, size email, and then this second one here is all the ones that are kind of not well known, but they're from Hibernate Validator. So if you use Spring Boot, they're already on your class path. There's some really interesting things in there, like @UUID, URL, loon check to validate a credit card number, unique elements if you want to check that all of the elements in a list are unique. I don't know if there's any Brazilians here. There's one that's called @CPF to validate like their social insurance number. So it might come in handy.
I know that.
Okay, good. Good. So again, slightly more complicated recipe here. We're going to start from the same template again, but we're going to add one special ingredient. So we're going to use Spring Boot test with explicit classes. We're going to import the relevant auto configuration. And here the auto configuration is called validation auto configuration. So oftentimes, if you're looking for the right auto configuration, there's one that's going to be called exactly what you want auto configuration. So validation auto configuration. I think it was 2 days ago, a colleague of mine was dealing with gRPC in Spring Boot, and I was trying to look at what the auto configuration did. So I just typed into IntelliJ gRPC auto configuration, and I found a class called gRPC server auto configuration that did exactly what it said. So overall, they're still fairly discoverable. And then the third thing we're going to do that's our little special ingredient is we're going to add a validation helper. And I'm going to show you how this works. So validation package. Here we have a record with some validation annotations on it. It says this device is only valid if the serial number matches this regex, if the model is not null, and if the location is not empty, but only check that if we're using the physical validation group. So how do we test this? Well, let me show you. Device test. Spring Boot test. Specify classes explicitly so that it doesn't load the whole application. Import our auto configuration, which is validation auto configuration. Remember exactly what we want, auto configuration.class. And then we're going to specify a little helper. And our helper is actually what I'm specifying here. And by the way, the classes you specify in here can be anything. I've had situations where the nicest way I found to disable the load everything behavior was to create an empty class called dummy and load dummy.class. So this is our validation helper, and it's something that I created a nested class inside of my test. It's annotated with @validated so that it will get some validation from Spring applied to it. And then there's two helper methods. One that says I want a valid device, and one that says I want a valid device, but I'm checking the physical validation group. And once we have this, oh, and by the way, if we do this here instead of using one of the classes from our application, then this test is really pretty well decoupled from our application because we're not relying on anything that has validation annotations in our application apart from device, which is the record that we're testing. So by doing this inside our test class and not relying on something that's in our application, this is allowed, right? This is not cheating. We're able to have much more flexibility. We can dream up all kinds of combinations that we want to test without relying on other things.
But if in your, say, controller you forget to annotate your controller with validated,
yeah, and
then the fact that you validated here does not really guarantee that your controller works the way.
Yeah, correct. So the comment was, if, for example, in your controller you have validation and in your controller you forget to add @validated, then this test will still pass. And my answer to this is yes, it will still pass because it's not testing your controller. So if you want to test validation on your controller, then I would, here I'm showing how you could test validation on the Pojo, like that your validation annotations are correct, but you can apply a similar strategy to test a controller that would be validated. And by the way, if you're using a recent version of Spring Web MVC, you don't need to add @validated on it anymore to validate request parameters.
Because people always forget it, because you think, oh, I already annotated my parameter, why would I need to?
Yeah, plus controllers used to have a separate validation path for request bodies, but not method parameters or not request parameters. So an @validated request parameter would give you a 500, but an @valid request body would give you a 400. So they changed it to be a simpler model. So just to reiterate, after we're done with our little setup, we auto-wire our validation helper, and then we can do whatever we want with it. We can pass in valid, invalid devices, see what happens, and therefore confirm that our annotations are correctly applied. And here I'm running it again to show you that it's a pretty fast test, right? And it will never grow in size or in time with the size of your application. Any questions on this? Awesome. Okay, so let's look at our third recipe now. And this one is about testing aspects. Who here knows or has done aspects in Spring before? Okay, so not a lot of people, and that's okay because it tends to be a more advanced subject. However, it's not that complicated, and if you develop Spring applications, then I suggest that you have a look at the aspect section of the documentation. By the way, they revamped the Spring documentation, I think last year or 2 years ago, and it's a whole different experience, especially if you've ever had issues with searching for specific keywords in the Spring documentation. They changed their search engine. It's much better now. And by the way, I'm not a Spring developer. I'm not from Broadcom. I'm just an enthusiast. So aspects are whenever you want to program things like whenever you have annotations like @before, @after, around, after throwing, after returning, there's other more advanced ways of doing it that I'm not going to get into. They're configured using something called the AspectJ language, of which Spring implements a subset, and I personally find that it's a pretty tricky language to work with. I forget the syntax every time I have to work with it and have to look it up or get ChatGPT to do it for me. So to test aspects, we're going to use, again, a similar recipe with a special ingredient. So we're going to use @springboot_test with explicit classes. We're going to import just the relevant auto configuration. And here it's AOP auto configuration. So AOP is aspect-oriented programming. So still pretty discoverable, right? Exactly what you need, auto configuration.class. We're also going to add our own little helper class with annotations on it. And then we're going to use a Mockito bean in a special way. I'm going to show you how that works. So I've written a little aspect here with an annotation called logged exception. And the idea behind logged exception is that every time a method is annotated with logged exception, if it throws an exception, I want to log the exception at whatever level is in the annotation. So this is my, you could think of something similar in a real world application. So the way we do this is with, with this aspect here. It's only, just this configuration will get it working. We say @aspect, @after throwing with some configuration here, and including this expression here. And this expression says I want the aspect to run, so I want this method to run whenever I have something that's in a class that's annotated with the annotation, or in a method that's annotated, and I want the method to be public and to start with save. So that's my example, and I've actually run into situations that were fairly similar to this. So how do we test this? Well, let's go to our test. Spring Boot test, import explicitly whatever you want as long as you have at least one class. Import our auto configuration, and then what we import here is our helpers, and let me show you what they look like. They're just two classes on which I wrote every combination of test cases that you could think of. So things where the annotation is on the method, things where the annotation is on the type, where the method is public, where it's not, where the method name starts with save, where it doesn't. So really every combination I would like to test. And this is where having it inside your test class is really useful, because you can basically write every combination you want without polluting your application. So once we do this, we can auto-wire our helper. Again, we perform, we run invocations on it. And the one thing that's our special ingredient here is that I want to validate if my aspect ran or if it didn't. And the way we do this is by using a mock instead of my aspect. So let me show you again what my aspect is. It's our class here that had a method after throwing. I want to be able to perform a Mockito verification and say, verify that this was indeed called. So we make it a Mockito bean, and just like that, we have access to validate our aspect. And let me run it for you, still pretty fast. And that's how I suggest we test aspects. Little caveat here, if you're on an older version of Mockito, make sure that you're using the inline mock maker, or else for technical reasons, this won't work. So, yes please.
Quick question on this. So, just help me understand, in this test1 method, you're just testing one of the combinations on your annotation?
Yeah, just because I wanted to make it easier on everyone.
You just wanted to understand that I'm missing something.
Yes, yeah, so but you're right.
In fact, if you wanted really to have a comprehensive test, you would have a test method for each of the...
Yeah, exactly. But I just simplified it so that the demo is easier to follow. But good point. The point was just that there's only one here. There's not a test for every combination, but it's on purpose. So my test is purposefully incomplete. Are there any questions on this? Anything? Okay, cool. So I'm going to assume that it's super clear. Now
it's complex.
Complex, yeah.
It's nicely complex, but it's clear.
Okay, good. Thank you. Okay, nicely complex, but it's clear. So thank you. I guess that's a good compliment. Okay, so now I want to show you how we can test caching, and I think this is already our last recipe. If you want, we can go into more detail about whatever questions you have or whatever use case you might have after this. But I want to show you how we can test caching. Caching is whenever you have annotations like @cacheable, @cacheput, @cacheevict, and I think that's all of them. Cache delete, I think. So we're going to use @springboot_test with a nested configuration class. We're going to import cache auto configuration. So exactly what we want, auto configuration, pretty discoverable. And then we're going to use a mock, not a mock bean, in a very specific way. And I'm going to show you why. Before I do, just one thing I want to say is that here, import auto configuration, there's another annotation that's called @import. If you use that one, it might or might not work. Depending on the situation, you can run into some very tricky issues if you import auto configurations using @import. Cool. So let's look at something that we might want to cache. And here I have an example where I have a cacheable method, and what it does is it sleeps for 7.5 million years and it returns 42. So if you ever have something like this, then definitely cache it. And then the second time, actually the reason why I put this example up here is that for caching, what I suggest that we're going to do is I'm going to show you how we can test caching independently from the implementation of our methods. So for example here, I don't have 7.5 million years, so we're going to run a cacheable test that will allow us to test only the configuration of the caching layer independently of what's in the method. Make sense? Okay, cool. So we're going to test that the method is called or not depending on caching, but we're never going to run the thread.sleep. On top of this, I have a little spell expression here that says I want the cache key to be just the message part of the descriptor here. And by the way, if you ever have a cacheable method where the arguments contain larger objects with a unique identifier, for example, they're a user and with a bunch of properties, and then you have one identifier, the user ID, you know it's always going to be unique, then it's a good idea to do something like this, because the complete user object will not be persisted in your cache. So if you have, if you're caching 5,000 invocations or 5,000, how do you say this? 5,000 different sets of arguments. You don't want to keep 5,000 big objects in memory. Maybe it's okay to just keep 5,000 unique identifiers.
Is this refactoring friendly? If in your record line 25 you rename message to message 1, will it change the key in line 16?
With IntelliJ, yes, it's pretty good for this.
Awesome. That's awesome.
Yeah. Please remind me to speak of spell comments after this. I want to say something about it. Okay. So let's go to the test. And again, Spring Boot test specify our classes explicitly. And why here this is not necessary, so okay, so yeah, this isn't necessary. If you have an add configuration, it will get picked up. You don't need to specify it explicitly. But basically what we're going to do is that since we want our cacheable bean to be a mock, but we also want caching to be applied to it. The mock bean and Mockito bean or Mockito spy bean or Mockito bean, what they do is they, if you use those annotations, Spring will not instrument the mocks. So it will not add transactional proxies or caching behavior or retry behavior or all of those declarative behaviors that you can add to your beans with annotations. They will not get applied to mocks. And that makes sense because if your mock is being cached, it could potentially lead to some very confusing situations. However, in this case, that's exactly what we want. So what we're going to do is we just give it a bean and explicitly ourselves say this bean is a mock. If you do this, someone said, will the mocks be reset or will the mocks accumulate method invocations? If you do this, they will because it's not using Spring's mock bean machinery. So you will have to explicitly reset your mock in an at before each. But here I only have one test method, so I didn't do it. And once we do this, we can simply auto-wire our bean with cache, perform some invocations on it, and then assert that it was only called the necessary amount of times. There's one little tricky thing here, is that it's that when we auto-wire this, it's not actually, what we get is not actually going to be of class or of type bean with cache. It's going to be something else that Spring generates that is responsible for applying caching behavior. And it's, I'm trying, let me see how we can, what's that?
It's going to be a proxy.
Yes, it's going to be a proxy. And so you're going to get, what you're going to get is you're going to get your mock wrapped in a caching layer. And the way that we can unwrap this caching layer to get to the mock is by using this little magic formula here, AOP test utils for aspect-oriented programming test utils, get our ultimate target object, and then once we do this, we get to the underlying mock, and we can perform verifications on the mock. So to basically check that our caching layer was triggered independently of the implementation. So let me run this, and once again, it fails. Let's see why. So apparently the thing that I commented out was necessary, I guess. Okay, so it was necessary. Don't have time to figure out why. But yeah, just wanted to show you that it runs pretty fast. So this is our last recipe. It's our most complicated ingredient-wise recipe. Are there any questions on it? Yes, please.
Can you please explain this test configuration again? Like this at the bottom you
Yeah.
have this bean with cache.
Yeah, so out configuration is the way that you specify beans to be registered into your Spring application. And here we're going to say, I want a bean of type bean with cache, but it's going to be a mock. So it's when Spring looks at it, it's going to say, oh, I see it has the add cacheable annotation. So it's going to apply caching to it. But the actual implementation of the method will be inhibited because it's a mock.
Okay, so in reality, we should not have been using mock. We should have been using an object that just accumulates the state that we can query, because the only reason why we use the mock is for line 40 to 42 when you essentially check the invocations, right?
If your caching annotations are on an interface, then yes, I presume that you would not have to use a mock. You could just use an object that you manually write to accumulate invocations, as you say. But here it's just a nice way of testing. Actually, it's the only way of testing classes without actually executing them.
Sorry, and can we just mock it as usual, like put
Mock bean?
mock it a bean, yeah, or
No. So the question was, can't we just write at mock bean like we usually do? That's way simpler. And the reason is no, because if you do this, Spring makes it so that the mocks don't get instrumented by, for example, by caching here. So the very technical reason is that the classes backing the mock bean and mockito bean annotations create a mock, register them into the bean factory using the singleton bean registry interface, and the contract of the method that it uses says if you register a singleton directly into the bean factory, initialization lifecycle callbacks will not be applied. Whereas this creates a bean definition, and Spring doesn't see that you're messing with it by creating a mock. So that's a very technical explanation behind it. Cool, and that's also, by the way, that's also the reason behind the Mockito 5 thing and the inline mock maker. It's because inline mock maker, what it does is it actually transforms the class that's in the JVM. So you're still going to have a class that's called bean with cache, except that the class will, if you dump it in a very special way, you'll see that it's full of very ugly generated code. That's because Mockito transforms it. Whereas if you use an older version of Mockito or not the inline mock maker, Mockito will create a subclass of bean with cache, and in Java, annotations do not get inherited. So when Spring will look at your mock, it will say it won't see the annotation because it's only present on the superclass of the mock. So yeah, that's a very, very technical explanation. Any other questions before we wrap this up?
Could you cover a little bit more? What is the role of those auto configs that we have to use
yes.
all the time?
Yeah. Let me. Which one would be? Yeah, I think this one is okay. So this is cache auto configuration. It's an auto configuration class, and auto configuration classes are classes that run classes that are able to look at how you configured your application and make some decisions based on that. So for example, here it's going to say conditional on bean, meaning I want to know if the user themselves have provided a bean of this type, and if not, they're going to provide something. So this is one thing auto configuration classes do. The other thing that they do is that they're registered automatically through kind of a service loader like pattern. So how can I find it? Cache auto configuration. It's in here. You'll see that Spring Boot has files like this, where it just looks at the file and discovers auto configuration classes based on files instead of component scanning them. So that's kind of a conventional way that your applications your libraries can provide configuration classes that will get automatically loaded into your application. Okay. Yes, please.
Yeah, I wanted to say that it's actually pretty cool that we have them, because I was worrying that when at the beginning you said that you just include all those bins you need, but if we use, like, for instance, tests on GPA or like even this cacheable or aspects, like there's so many internal stuff that we need to include, and it's like people will not be able to remember it.
Fortunately, at least for the examples that I've shown, I think that this generalizes pretty well, but for a lot of cases, you'll find one or two auto configuration classes that you can rely on. Cool. So some other considerations that I have: if you choose to use strategies like this for testing your application, then it's still important to have at least one test that loads your whole application, because that's the one that's going to catch configuration errors. If you have missing dependencies or unresolvable dependencies that would lead to your application not being able to boot, then it's important to have one test that will exercise the whole context configuration, so the whole application configuration. Second thing is that you might have noticed that in all those examples, or almost all of them, I always had a configuration class that I imported from my application. And this configuration class had an annotation like enable scheduling or enable validation. It would also have worked if I had enable validation directly, say, on my validation test. However, if you do this, it's very dangerous to run into some false negatives, because if you have enable validation on your test class and someone forgets to add or removes enable validation from your application, then your test will give you a false sense of security, and you'll end up pushing to prod something that doesn't have caching, doesn't have validation, doesn't have security. And it's a very easy mistake to make. So my recommendation is, if you ever see @enable something on a test class, remove it. Remove it if the application still passes, or if the test still passes, good. If the test fails, then you found a bug. And then finally, I recommend that you use configuration classes that are smaller and that are responsible of a single vertical of your application. The reason being that when you want to import relevant configuration classes into tests like this, if you have a massive configuration class that's like my application configuration with all of your JPA, caching, validation, method security things in it, then all of your tests are going to have to worry about all of that. Whereas if you have one class called caching config that only contains your config for your caching, then you can import caching config, and you get some very nice isolated tests. In conclusion, smaller tests are faster, they're more flexible, and they're easier to troubleshoot. Thank you.